Hey guys, this is Miss Morrison. This is the first video of lesson 2, but I messed up already, so I have to redo it. Okay, when we talk about degrees of a circle, we can also talk about how many rotations we went through in a circle, or we can talk about how many revolutions of the circle we passed through, or we can talk about radians, as in one whole circle is 2 pi. Or we could even talk about angles in terms of minutes and seconds. And that's actually what latitude and longitude does. They talk about angles in terms of the degree, the minutes, and the seconds. And we've already talked about that. Okay, so let's see. If I want to convert 255 minutes to a certain amount of hours, I know that there's 60 minutes in an hour. Okay, so if I divide by 60, I want to know what it is. And then I have to turn it into a mixed number. So I know that 60 can go into 255 once, 60 twice, 3 times, 4 times to get 240. So it's definitely 4 some kind of hours. But what's the difference between 255 and 240? Well, 255 minus 240 is 15. But I'm not going to say 4.15 hours. No, because this is 15 out of 60. So I'm not going to say 4.15. Because that 15 is out of 100 spaces. Get it? 10th, 100th. We want it to be out of 60. So instead, I'm going to say 4 hours, and we have 15 minutes remaining out of 60. This is the same thing as 4 and divide by 15, and it should get you 1/4. Or if we want a decimale, that's 4.25. Okay, so we converted it to hours. And if it says improper fraction, use the 4 and the 1/4. That's what the improper is. If it says some kind of rounding, use 4.25. If it says something, I think that's all it will say. All right, let's try this 150 minutes. Well, we divided by 60, and 60 goes into 150 twice, for sure, right, to get 120. 60 times 1 is 60. 60 times 2 is 120. Okay, so we definitely have 2 hours. And then what's left over? Let's see. If we have 150 and we take off 120 for 2 hours, that leaves you 30 minutes. But I'm not going to say 2.30 because this 30 that I wrote after the decimal represents 30 out of 100, because this is in the 100 spot. Whereas 30 minutes should be rewritten as 2 and 30 over 60, because there's 60 total minutes that we could have on a clock. Okay, so this becomes 2 and 1/2, or just 2.5. All right, let's look at area and circumference of a circle. Area of a circle is pi r squared. Circumference is 2 pi r. And circumference is a big old fat capital C, and area is a big old fat capital A. Okay, so let's find the area of a circle with a radius of 7 1/3 meters. What? Okay, so first let's find the area. Area means how much of that circle, what's the surface area? So if I'm looking at this lid, okay, area is all this stuff. Circumference is just the edge around. Okay, so area is pi r squared. So that's pi. And then let's change this 7 1/3 to either an improper fraction or a mixed, no, an improper fraction or a decimal that stops and terminates. I don't think this terminates. It keeps on going. It's like 7.3333333 for the rest of your life. So let's make it improper. To improper it, you multiply. 3 times 7 is 21. And then you add the number on top. So you say 3 times 7, 21. Plus that 1 is 22. So a radius of 7 1/3 meters is the same thing as 22 from 3 times 7 plus 1 all over 3. All right, let's go. So that's my R. And we want it squared. And the reason I'm changing it is from a mixed number is because in pre-cal, we don't really ever use mixed numbers. The only time we ever really use mixed numbers is when maybe we're talking about cooking or tablespoons or something. But now that we're in pre-cal, we use improper fractions and decimals that stop. Okay, so anyway, pi r squared. Let's see. If I square that 22 over 3, it's gross, but let's see what happens. And I think I'm going to put it in parentheses, 22 over 3 squared. Ugh. Okay, and it comes out with a decimal, but then press math. Enter. Okay, so we have this crazy decimal, and you're going to press math. Then that arrow frac means take me to a fraction. Okay, so press enter, and now you're telling the calculator to take you to a fraction. Hey, 484 over 9. Okay, and if it was reducible, it would have already reduced it for you. So my area is 484 over 9. And then remember how there was a pi? We put the pi on the top. Okay, so this is what we call the area in terms of pi. It's called in terms of pi because the pi's still there. Yep. Okay, now let's put it in the calculator. To get the decimal, let's say 484. And then to get that pi, you have to press second and then the caret button. And then go ahead and divide by 9. Okay. So 484, second caret, that makes the pi, then divided by 9. And I get 168.9. Yeah. Your homework will tell you what to round to. Okay, what are the units of this? Both of these are in meters, which is just the letter M. Okay, and then the difference between these two suckers is this 484 pi. That's what we call exact. And it's exact because it's not rounded. We need exact values for if we're like trying to shoot somebody out of a cannon or if we're trying to fly a plane. We need exact values, not rounded decimals, because the rounded decimals could mean a difference of 1 apple or 40,000 feet in an airplane. You know, it could be anything. So this sucker with the pi is the exact. The decimal is the approximate or the estimate or the rounded or whatever you want. All right, let's do circumference. Circumference is 2 pi r. So we're going to say 2 pi times that r of 22 over 3. Okay, and then you're going to multiply the numbers together. And we're going to remember that 2 is like saying 2 over 1. And then you multiply left to right. Let's not put the pi in the calculator yet. So for just now, 2 times 22 is 44 over 3, and there's a pi on it. And we're in meters. Okay, so that's my circumference in meters. If you're thinking that's miles, MI is miles. Okay, now if we want to, that's the exact. Now let's find that approximate. We're going to say 44 second caret. That'll give us the pi divided by 3. And the caret is right here. The second is that blue button. And we get 46, maybe 0.1 meters. I just rounded to the 10th. On your homework, you'll have to check and see what they want you to round to. All right, let's keep going. Another area and circumference problem. Okay, for part B, it looks like all I have is just a circle with a line through the middle, and it says 15 mm. That means millimeters. Okay, well, let's go. Our area is pi r squared, but this 15 is the whole thing. I just want to know halfway, because halfway is whatever your r is. So r is 15 divided by 2, and that should pop out just 7.5. So that's our r, 7.5 millimeters. Okay, let's go. We're going to say pi, parentheses, 7.5. I won't put the millimeter for now. Oh my goodness, I forgot. Circumference is always your regular unit. So here it was meters. But area is always your unit squared. Oh no. So we got to put a squared on this little M on part A for the areas. My bad, I forgot. And then volume, if you wanted to know, it would be cubed because we're jumping up a dimension. Yeah. Okay, so we have pi times 7.5 squared, and then whatever this is, it's going to be millimeters squared. So let's do 7.5 squared. And let's press math, enter, enter. And this gives us 225 over 4 pi. And that's millimeters, and it's squared. Area, circumference is just your regular unit, like meters. Area is your unit squared. Volume is your unit cubed. And if we had a fourth, and if we lived in 4 dimensions, that would be our next letter, but we don't live in 4 dimensions. Okay, we live in 3 dimensions. Now let's put this in the calculator. We're going to put 225 second caret, and that'll put the pi on there, then divide by 4. Ooh, okay, and we got 176.7-ish millimeters squared. And you would check your homework for what they want you to round to. Okay, now let's find the circumference. The circumference is 2 pi r. Okay, you might see something already. Good for you. Okay, so that makes 2 pi times my r of 7.5. Okay, to get our answer with the pi in it, we're just going to multiply those numbers. 2 times 7.5 is, let's see here, 15 pi. All right, so my circumference is 15 pi millimeters. All right, let's actually put the pi in the calculator. So 15 second caret. That'll slap the pi up there. And it looks like we don't have to divide by anything this time. Huzzah! So 15 times that pi will make us 47.1-ish millimeters. And then again, circumferences have your regular unit. Area is unit squared because you're multiplying two numbers together. And then volume is cubed because you're multiplying three pieces together. All right, the next thing we're going to cover is standard position. And I don't have my little cute Temu slider with me. Dang it. Oh, well. Okay, standard position is where you start on this positive x-axis. So this is the x-axis, and you start drawing your angle by putting it out, okay? Yeah. And then you draw up and around if you're positive, and you draw down and around if you're negative. Okay. So, oh, and let's remember that every quadrant is 90. Okay, so if I were to draw this, 0 is right here. Then you go up and it's 90. Another quadrant is adding another 90 or 180. Another quadrant is adding another 90 or 270. Yeah, okay. And then now let's start. I'm going to draw my dot right here on the positive x-axis. Okay, my angle is a plusative, so I'm going to go up and around. I just crossed through 90. I just crossed through 180, but I need to go to 210. Well, 210 is somewhere over here. It's almost to 270. Okay, so this would be standard position. And when it says quadrant of terminal side, what does terminal mean? Well, if somebody says you have a terminal illness, that means something is about to come to an end, you know? And so terminal side means where does that angle end? Or where does it land? That's what terminal means. Okay, so I started on the positive x-axis. I ended over here. What quadrant is this in? Well, we say 1 is that top right, 2, then 3, then 4 is IV. Okay, so it said draw the angle in standard position. We did. It's this hoopty arrow thing. Okay, then it says give the quadrant of the terminal side. Well, we're in quadrant 3. Hey-o. Okay, let's go to part B. It says 300. Same thing. We start over here on the positive x-axis. We draw up and around 300 degrees. Well, let's see here. This first quadrant is 90. Then we get to 180. Then the next quadrant is 270. But then I need to go a smidge more to get to 300. So let's go a smidge more and draw that crooked terminal side from the center or the origin out into the space. So from the origin out into the space. Okay, and then it says, what quadrant did we land in? Well, this is quadrant 4. All right, let's go again. Negative 45 degrees. We always start on the positive x-axis, and then negative means we're going to go down. Well, if I go down, my negative 90 or my 90 degrees is now at the bottom of my picture, and it's negative. Okay, negative 45 is halfway in between. And then that crookedy diagonal from the center out into the quadrant, that's your terminal side. Okay, the question was, what's the quadrant of the terminal side? It's quadrant 4 again. All right, let's go again. Negative 100. So we're going to start on the positive x-axis. But because it's negative, we're going to go down. And we're going to go down all the way to 100. So let's see here. If I go down, straight down, that's just to negative 90. And then a little bit more is 100. Okay, so I went down and around to negative 90, then I went a little bit more. Okay, and it says, what quadrant is this terminal side in? Well, quadrant 1, 2, 3. 3 is 3 eyes. Okay, let's go again. 420. Uh-oh, that's too big. Look at the next one, negative 390. What? That's negative and too big. Okay, if you have a number bigger than 360, you're going to subtract off 360 because all the way around a circle is 360. So to get to 420, we definitely have to go once around, all the way around, one spiral to make up the 360. Okay, and then if we subtract these, I get 60 degrees. Yeah. So when we draw, we're going to draw one spiral and 60 more. So we're going to spiral around once and then go 60 more degrees. Okay, let's see here. We're going to start on the positive x-axis. And I said we're going to spiral around once. That takes care of the 360 degrees. Okay, and then it says we need to go 60 more. Well, where's 60 degrees more? Does it pass over this 90? No, I went one spiral and then 60 degrees more. Okay, and the question was, what quadrant is your terminal side in? Well, even though I went around a couple times, around once, my terminal side is still this top right quadrant. So quadrant 1. Okay, let's look at this negative 390. Okay, that's too much. Either way, it's too much. We only go up to 360 on a circle. So let's see, if I subtract 360, what happens? Sorry, negative 390 minus 360. Negative 750. That's not what we want. Too big. No, we're trying to get something that is on our unit circle or something that's below 360 degrees. Okay, so we're going to add instead. So let's add 360 degrees. Okay, and we're going to get, I think, negative 30 degrees. Okay, so let's think about this. That 360 is going to be one spiral. And then 30 degrees more. Yeah. The only thing is we need to be going backwards because we have a negative that we started with. So I'm going to start at the positive x-axis. And I'm going to go down and around. I'm going down because it was a negative angle to start with. Negative 390. So I went down and around. That's one spiral. Or that's 360 degrees. And then I'm just going to go a little smidge more of 30 degrees. Yep. So we went all the way around once for 360. And then we went a smidge more, 360 more. Okay, and what quadrant is this in? 4. Hey-o. Okay. Let's go back to time for a minute and talk about degrees, minutes, and seconds. The symbol for degree is that little circle in the air. The symbol for minutes is that little apostrophe or like one tick mark. Seconds is a double apostrophe or 2 tick marks. And I want to take things that look like minutes and seconds. Like, look at part B. It says 63 degrees, and then we got 21 minutes, 28 seconds. I want to change that to just some kind of decimal degree. Yeah. So I want to take away these tick marks somehow. Okay, well, let's think about this. This is 38 minutes. Okay, so to create the decimal for that, I'm not going to say 38 over 100 or 38 over whatever. We are going to say 38 over how many seconds is in a minute, or however many minutes is in a second. So either way, it's 60. So 38 divided by 60, that's going to give me my decimal part that I wanted. And I get 0.63 repeating. Yeah. So my decimal degrees is the 304. That's like the whole number, the whole part to the left of the decimal. So we're going to say 304. That's the whole part, or the part to the left of the decimal. Then we're going to tack on that 63 to the right of the decimal. Yeah. Okay, so our decimal degrees is 304.63. Or if you wanted to round it to the 10th, it would be 0.6. Okay, yeah, look at your homework to see what they want you to round to. All right, let's go to part B. Same thing. This 63 degrees is going to be the whole part, whole with a W, the whole part of the decimal. So it's going to be 63 decimal. Then I'm going to take that 21 and divide it by 60 and get his decimal. Let's see. 20, nope. What? No. Okay. 21 divided by 60. That's 0.35. Okay. Ooh. And then now we're going to take this 28 and convert it. Okay. This 28 is a double tick, so seconds. Okay. If I'm trying to take this seconds and convert it into hours, like I did the minutes, then I'm going to divide by 60 for sure. But I'm going to have to divide by 60 twice, or by 60 squared, or by 3600. So when you convert minutes to decimal degrees, you divide by 60. When you convert seconds to decimal degrees, it's kind of like converting seconds to hours. You have to divide by 60 twice. So we could say 28 divided by 60 divided by 60. Or you might have seen in your homework 28 divided by 60 squared. Either way. So we get 0.0077. Okay, and then you're just going to add all three of these numbers. 63 plus 0.35 plus 0.0077. And look, they just naturally kind of squish up together. So we get 63, and then the 0.35 drops down, and then that 77 gets tacked on the end. Or added up in your calculator if you didn't understand how that worked. Okay, so we get 63.3577. And if your homework asked you to round to a certain spot, then you would. All right, for this 27.103 degrees, we're going to go backwards. Okay, a way we can go backwards is to use our calculator. We can type 27, like the regular number 27. Then I can press second, apps, for the little degree symbol. So let's try typing that in right now. Oh, and also my mode has to be in degrees. So before we even start going, our mode has to be in degrees. Let's see. I'm going to press the mode. You see it, mode? Okay. Press the mode. And then go down third or fourth line, and degree should be black. If it's not, then you press the arrow button, scroll over, and just press enter on top of degree. Okay, so now our calculator knows we're talking about degrees. So I'm going to type 27, second apps, and then look there, look at that little degree symbol. Okay, press enter. Poop. My bad. Let's type this whole thing. Okay, not just 27, type the whole thing. 27.103. We have to type this whole thing. 27.103. And then second apps, enter on that little degree. And then now we want to convert it to degrees, minutes, seconds. So we typed in 27.103, then second apps, enter. That got us all this. Then we're going to go back to second apps. And there should be something that says DMS with like a weird little triangle thing. We kind of saw something like that when we were looking at the math, enter for taking decimals to fractions. Same thing here. I'm going to, after that little degree, I'm going to press second apps. And I want to choose the one that says little triangle. That means take me away to degrees, minutes, seconds. That's what DMS means. Degrees, minutes, seconds. So let me go down to degrees, minutes, second. Take me away. And then press enter. Hey, there it is. I got 27 degrees. 6 minutes and 10.8 seconds. Woohoo! All right, now we're going to learn how to convert from degrees to radians. And then I want us to write our answer as a pi and as a decimal. Okay, so yeah, there's a couple of different ways we could do this. One way you might think is, okay, let me try and explain what we're doing. We're trying to represent this 30 degrees, which is just, a slice of that 360. We're trying to represent that slice in terms of pi. Yeah, okay. So the whole circle is worth 360 degrees. So if I wanted to, I could say that 30. No, never mind. Okay, anyway, so to convert, we want this degrees, this little circle, to go to radians. Well, the information that we're going to use is 180 degrees is equal to pi. And we know that because 0 is the positive x-axis, 90 is the tip top, 180 is the very bottom. Okay? And we know that all the way around is 2 pi. So that 0 degrees is the same thing as 2 pi. Okay? Well, if all the way around is 2 pi, halfway around is 180. And that's our unit of conversion. You remember when we were changing minutes to seconds or whatnot, we were dividing by 60. Yeah, okay. Here, we're going to deal with 180 and pi. That's our conversion factor. Okay, so to get this degree to cancel, we want to put whatever is from our conversion that has the degree in it down below. So I'm not going to put pi down below because the little degree symbol won't cancel. I'm going to put 180 down below. See 180 degrees? And it's equivalent to pi. And then let's see what happens. The degrees cancel out, like those little zeros in the air. And we just have to figure out what 30 over 180 is. Well, one thing you can do is you can try and reduce. And you can say 30 goes into 180 6 times. There's supposed to be a 6 on the bottom. Or we can use our calculator. We can say the 30 on top divided by 180. And then you probably need to press math, enter. And if we do that, we get 1 over 6. So this 30 divided by 180 is 1 over 6. But if I were to multiply this, I'd multiply 30 times pi and then divide by 180. Either way, the pi stays on the top. Okay, and 1 pi over 6 is the same thing as pi over 6. Hey, we just rounded this. We just found the radians. Radians means how many pi's? Okay, so that's one way you could have gotten 1 over 6. Another way to get 1 over 6 is you could just say 180 divided by that 30 is 6. Yeah, and you could say, okay, well, that makes the 30 a 1, and that makes the 180 a 6. Or you can just put it in your calculator. Doesn't matter. All right, so that's pi over 6 radians. At the decimal, we press second caret divided by 6. And we get awkward point. Actually, in your homework, I think you have to put the 0 to the left of the decimal or else you get wrong. I know it's like that in statistics. Okay, so 0 point, let's say 5,2,3,5. Oh, it wants it to 4 spots. So I wrote down 4 spots, but then I need the 5th spot to tell me what to do. Okay, so when you write round to 4 spots, you write 4 spots down. Then don't forget to write that 5th. And that 5th tells you what to do. So this 5th number is 9. So that's 5 or more. So we're going to up that score. So instead of 5235, this is 0.5236. Shablam. Yeah. Okay, and both of these are radians. All right, let's go to 60 degrees. To convert it, well, we're going to use this conversion factor, this equivalent. 180 degrees is equal to pi. Well, if I want the degree to cancel out so that we just have my pi's left over, I got to put 180 on the bottom. And some of you might be asking, hey, can we use 2 pi and 360 instead? 100%. Yeah. So if you wanted to say 60 degrees is multiplied by 2 pi over 360, you could do that. Either one. Okay, if we're doing this pi over 180, that means we have to put in our calculator 60 divided by 180 and then math enter. If you do that, it should pop out 1 over 3 and then you slap a pi on it. Or just pi over 3 since we're grown-ups. We don't need that 1 there. Okay, if you multiplied by a conversion of 2 pi over 360, that's what came to my mind at the very beginning. Then in your calculator, you would do 60 times 2 first. You have to do 60 times the number on the top first, then straight up after that, divide by 360. And let's see what happens. 60 times 2 divided by 360. Hey, 0.3. Math enter. And hey-oh, we get 1 over 3. But then we put a pi on top because that's where the pi was. Then we grow up and we quit writing that 1 on the pi because it's understood or it's imaginary. You don't have to put it there. Okay, let's look at 45. Well, you're going to multiply 45 by pi over 180. The degrees can't go out. In our calculator, you're going to type 45 divided by 180. Math enter. 45 divided by 180. Then this math. And then it says, take me away to a fraction. Yes, enter. and you get 1/4. Okay, but then we put the pie on top because the pie was on top. And then we grow up and we don't put 1 pie because we know what that is. That's just pie. It's kind of like 1x. I think I forgot to find the decimal on the last problem. Okay, if I want to find the decimal for pi over 4, I'm going to say, I got to type the pi first. So second caret divided by 4. And remember that caret is right by the clear and the division sign? Okay. So pi over 4 is 0.7. Okay, let's write this down. 0.78539. And we want to round to 4 spots, so that 5th spot tells us what to do. And he's 4 or... No, he's not. He's 5 or more. So we're going to up the score. And when I say up the score, that means this 53 needs to change to a 54. So we get 0.7854. All right, let's keep going. 90 degrees. If I multiply that by pi over 180, in your calculator, you're going to say 90 divided by 180. And it should pop out, after you press math, enter, 1/2. But let's remember we're grown-ups. Let's remember the pi was on the top, so put the pi back on the top. And then now we're grown-ups. And grown-ups don't write 1 pi. They just write pi. I don't want to be grown-up. Ah! Oh my God! Hold on, sorry. Somebody just scared me. Walked into my office. I'm sorry. Okay. Hold on. Let me stop.